Hello everybody, guys and gals. This is a very special video in ARIS Epi history of this YouTube channel. We hit 69 subscribers. As we can see, this is a very, very special milestone. First, before we get into the math, let's examine this number 69. What makes it so special? So you may be asking, well, it just looks like a number. But if you look at this here, 69, 9 is just an inverted 6. It's just flipped 180 degrees. So it just it looks funny. So that's why 69 is so special. So I have a special math problem planned out for this video, and we're gonna go over it together. It's involving integrals, okay? And this this channel has a long history of integrals. I love integrals. I feel like they're better than derivatives, okay? So the integrals we're having today. So we have a double integral. So last math video, we learned double integrals. So we have a double integral from 0 to pi, and then 1 to, 9, of x sine y, dx dy, minus the integral from 0 to 2 of x times 3x squared minus 2 dx minus 4. Okay. So what is so special about this integral? These integrals, I should say. Well, we'll find out, right? So our approach here is we're just going to take the integrals of each function. So we're going to start off with the double integral. So if we remember how double integrals work, we have this rated integral. So we first take the integral with respect to x here. This marker's dead. So we would have first the integral is from 0 to 9 of x sine y. So the integral of this, well, the y is just a constant. We don't need to worry about that. So we'll have the integral from 0 to 9 of x sine y. Well, the integral of x, that's just x squared over 2. So we'll have x squared sine y over 2. Okay. And then now we plug in our bounds to it. Not 81, 9, 0. We're not going to count y because this is only for x. So we'll have 81 over 2 sine y. I'll just combine the bases, actually. I'll just do that. So we have that. Now it's time to take the integral of this function here. So we have the integral from 0 to pi of 81 sine y over 2. Okay. Now let's look at this integral. This is a fairly simple integral, I forgot to put the dy right here, the dx. Okay, so it's a very simple integral. What we'll do is break this apart. So we have 81 over 2 times sine y, which is what it is. And we'll bring the 81 in the front as a constant, okay? So that's just what we're doing. So bring it forward, we'll have 81 over 2 times the integral of sine y. Of course, our bound 0 to pi. So we just integrate that. We get negative 81 over 2 cosine y. And then our bounds pi and 0. Okay. Now first, so cosine of pi, that is negative 1. Yeah, negative 1 times the negative 81 over 2. That'll give you 81 over 2. Fairly simple. Now minus, so cosine of y, that's 1. Or no, cosine of 0, I meant to say. Now cosine of 0 is just 1. Remember our unit circle. So we'll have 1 times negative 81 over 2. So that'll give us 81 over 2. We simplify that, that'll give us 81. Okay? So that is our first integral solved. So this right here. So let's write it down. So we get 81 minus now this integral here. Let's focus on this integral. So we're going to have to use u substitution, and I brought this up in the first video a couple months ago, how to do u substitution. Okay, so u substitution is pretty much the chain rule of integrals, okay? And yeah, so let's do it. So integral of 0 to 2 of x times 3x squared minus 2 dx. Very simple integral. So if you want to do it, just pause the video, but I'll do it. So we have u is equal to, what we want to substitute is 3x squared minus 2 dx, and then du, which we just take the derivative of that function. It'll give us 6x dx. Now what we want to do is we want to get du equal to dx. Okay, so for this to happen, we have to divide by 6x. So fairly simple stuff. So let's plug this back into here. First off, let me just separate this. This is kind of messy. Okay, let's plug this u and du back into here. Okay. So what we're gonna have to do is take out the constant first. We can take out the constant first. So we'll get 1/6 x. Actually, the x's cancel out. We have this x here and the other x. Those will cancel out. Okay, so let me just mark. Those x's will cancel out. So we have 1/6 the integral of u du. Now the integral of u du is fairly simple. Maybe a little challenging for some people, but if you watch my other videos, you can get this. Or even the other example. They'll give us u squared over 2. Yeah. So now we're going to plug in our u, which was 3x squared minus 2 squared divided by 2. Now, our final step, we got to plug in the bounds. Okay. So, what is this? 2 squared is 4, times 3 is 12, minus 2 is 10, 10 squared, that is, I made a mistake. So, we have to multiply the 1/2 by 1/6, so it gives 12. So, this will give us, 10 squared, 100 divided by 12, and then we have to subtract it by 0. Subtract, and now we plug in 0 in here. So 0 squared times 3 is 0. So negative 2 squared is 4 divided by 12. We get 4/12. That'll give us 8. We get 96/12 and just divide it by 8. So let's bring this up. Let's bring it up here. So now we have these two integrals covered. What do we do next? Now we have to subtract them. Now 81 minus 8. And it's probably the hardest part. Okay. 81 minus 8, 73. 73. Okay. Yeah, so we're almost there. Now we have to subtract 73 by 4, and we have our final answer. Now that's the problem where this part is where a lot of people stumble, because they don't know how to subtract. And I personally don't know how to subtract. These mistakes here, if you make a mistake, can bring your grade from 100 to a 97. It's sad. It's a sad reality, but people make mistakes. So 73 minus 4 is equal to 69. So that's our final answer. Now, this problem was specifically designed by me. I didn't look it up. This is designed by me. So, I don't know. Leave a like, subscribe, comment down below. What was your favorite video in the past 69 subscribers? And if you want another cooking video, 70 subscribers is coming up, so make sure to subscribe. So that has been, I'm trying to find my controller. That has been the 69 subscriber special for Arid Zeppy. Hope you enjoyed.